Okay, in this video, I'd like to show a quick and no-nonsense way of making a buckyball in CAD that doesn't result in messy edge self-intersections. I've done other videos on this. This is just going to be me doing it relatively quickly. So we are going to find on our polyhedra an arc that if we cut a arc through the surface, it spans a 90-degree or 180-degree arc. I bet there's some 120-degree arcs out there on other solids, but this, we are starting from an edge, and we can take the midpoint of this edge. From this point to this point, we're going through the midplane. From this point to this point, we're going through the midplane again. And if we look at this, we kind of spin it around. This is obviously 90 degrees from that. So if we can define an arc that spans that bit of geometry, which we can easily define if we swing these planes, these face planes into the sketch plane, this means we can get all of this geometry for free. And let me show rather than tell. So start. We're going to take a plane. Let's keep it all centered on the origin. That makes everything else easier. Take this is the top. We just saw before. Let's horizontal. Make this up a little bit. And here's our pentagon. Glue this to this with a coincident. Grab this over here. Get it kind of close to where we want. These things kind of like to run away. Let's make sure that can stay nice and normal. This guy wants to be glued to here. Okay. It's just going to fight us. And make another one. We're going to make a hexagon over here. And it's just going to try to glue the geometry to random places, but we're not going to let it do that. So, incident line through here. Make a line to here. Now this is perpendicular. These looks noisy looking. We're going to make our complete our 90-degree arc. And still, this looks dumb because this is not equality to this one. This is still fighting us because we didn't make this one equal to this one. So now what we can do, we can just put a circle, sketch construction geometry, and then set this to the diameter we want the points to be at. So 200 is nice and even. Notice how it's all locked in. Very few operations. So I think of this as a visual proof. This is not like to get this sort of geometry. Otherwise, you have to really jump through a lot of hoops and look up things, look up numbers, and like this just fucking works. So this is what I've been sticking with. Now we're going to take a plane, an angle plane on this edge here. Swing this 90 degrees back into plane, which you'll see if we look back here. This gets us back into plane with this face, which we know is perpendicular to this face, which passes through the midline. We're going to do this twice. And another kind of nice trick is we'll do a loft in a second in kind of a slightly clever way. But we'll get there in a second. Now we're just going to use this line U. another pentagon. Glue this one to here. Glue this one to here. I'm saying glue, but it's coincident, whatever. Hide this plane. And let's hide these guys. Fine. We're going to do this a second time. You could also do this with the revolve. Like, it's just messier, and then you have to deal with an extra part count. Maybe make sure it's referenced off of this normal line. Great. And we're going to create a sketch on that new plane. We're going to project this edge from our base sketch into plane. I know that's going to fight us earlier because we didn't make it a construction line, so let's make it sure it's not going to, we don't have to extrude two regions for the next step. We're going to do a hexagon. Do a hexagon that's not. We're going to do a hexagon that is not construction geometry. Save us a step of clicking a bunch of things. Great. Glue this to the midline of this. It's giant. Just so I don't wanna make a sketch point on midline. Grab this, coincident. And now it's all locked in. Cool. We're gonna hide our plane. We could name these, but I don't want to right now. So what we have now is we have our two faces of our thing. I'm just going to hide this for clarity for a second. What we're going to do, we take we're going to loft this, and see, that's fighting us, but I don't care right now. You can make that midline not a construction geometry. Okay, look, it's fighting us. So, note to self, note to you, make this midline construction, otherwise it fights you. So we're going to go back. We're going to fix that. Make sure this, yeah, lofts are kind of fussy. So let's do this again. Here we go. This face to this point gets this really nice, dead easy little pyramidal solid. We're going to do this again. This time, make sure it's new, not adding, so then we're not gluing stuff together that we don't want to. See, it's trying to add it. Make sure it's new. Now, we're going to show this again. And from some trial and error, I know that this kind of can be a little fussy, so now we're going to sort of propagate these pyramidal solids down and around our polyhedra. Do this one around here. Way to think of a buckyball is no pentagons are touching any hexagons. So we're kind of half of the sides. Let's grab this one. We're in a circular pattern. This guy around this axis 5 times. Cool. And we're going to circular pattern this around this axis 5 times. So we're going to skip that last one because we already made it. Skip instances this guy. And notice now it's not doubling itself. Oh, and just for hexagon over here. So I'm trying to tack towards having a nice half and half polyhedra here. There's a lot of ways to get here, and so yeah, let's do a mirror. Mirror on this thing. Yeah, the combination of mirrors and circular patterns, you can pretty much kind of get these to move around the solid pretty easily. Yeah, let's just do this one 5 times. Circular pattern, this guy, 5 times around this axis. And I think, yeah, that's our half now. From some trial and error, figured out that pretty sure this guy here, the midplane of this face is going to be a nice bit of rotational symmetry if we want to just not do that a bunch of times. So we can actually just select this whole situation. This might bite me, I'm not sure. Circular pattern around this axis twice. Okay, didn't fight. Amazing. So there we have it. Got about relatively few pieces of design history. We went from something like this, where this is just very simply defined. I can change this way at the beginning, kind of to whatever I want, and the change automatically propagates through. Okay, that comes at no surprise, but if you try to do this with really sort of fragile sketch geometry, it's going to break and it's going to get like projected features. Things get really fragile. What we get from this, which is like pretty cool though, doing it full solid, is we can take a face here and just pick a random piece in the middle here. And we're just going to get an arbitrary asymmetric projection of our solid. And like, I could even do this with an ellipse or something. Let's make it 100. Make this just 10 so it doesn't get too squirrely. I can bump this up a little bit, 150. Cool. So now we have a slightly asymmetric projection of the thing. We're going to take a revolve, hide all the parts for a second so we can see the core here, revolve it around here, intersect it with merge with all, and there we have it. We have our slightly asymmetric soccer ball. Just to make it more obvious, let's bump up this thing here. It's slightly more asymmetric. And like, you could do this with an arbitrary solid in here. Bigger, smaller, bigger, smaller. I haven't seen anything that is able to do this as quickly, that is software agnostic, that doesn't require lookups or trig. Some people are going to look at their nose at this and be like, oh, okay, you're doing it in the solver, or like you're doing it in the sketch geometry, and like, this is a visual proof of what a dodecahedron is. This is a path that's clearly traced along the surface. You could even label your sketch. Like, whatever documentation you need to prove this to whoever's breathing down your neck, telling you to make your dodecahedron, make your buckyball faster. Like, I think this is very clear and almost self-documents. So, yeah, this is another take at explaining this slightly novel technique and getting it in more brains. information sharing is important, and yeah, more people making cool objects out there, the better. So feel free to ask me any questions. I'll be checking the comments and seeing if anybody is actually interested in this stuff. I tried to do the same thing with a Goldberg solid a bit ago, actually, and the weird thing about these is you actually, I had to do a lot of really heinous stuff to get here because if you look at the pattern of these, there's actually the hexagon. This is an icosahedron, but this path here, these hexagons, since they're spanning an edge, these are actually slightly saddle shaped. So my technique doesn't play nicely, and I had to do some really weird stuff to get them to everything to kind of line up nicely. But just to like show that this is a full solid, like relatively large geodesic thing, like this. Yeah, I don't know. I think this sort of technique pretty speaks for itself. I don't know. Catch you later. Thank you.